Today, I want to talk a little bit about self-healing tests. Motivation, what motivated me, why I have even investigated into the topic. First, I want to make a statement. This is software, or test automation is software development. Hopefully, everyone is in this opinion. If not, we can definitely have a great discussion afterwards in the Q&A. But for now, test automation is software development. This means it needs to be sustainable, it needs to be maintained, it needs to be refactored, it needs to get the same attention as business-related code. Yeah, this is very important. And maintenance, especially, maybe you know or know all that this is, yeah, expensive, sometimes disgusting, annoying, and of course, I want to decrease this maintenance effort. And if you get the test reports, yeah, from the test execution, from the test automation, from the pipeline maybe, and then you have some failing tests, and you have to do then root cause analyzing. Yeah, and this is very time consuming, and especially if you have then some patterns. Yeah, you see, for example, a locator change in something like this, then this is really annoying. Yeah, and I was like, come on, there has to be a solution outside, or why I have to do things same, repeat myself. Yeah, because I'm really automate practitioner, something like this. Yes, I really want to automate things where I see I repeat it. And so I started to research. And here I found some numbers, some quite well-known companies like Gartner and also Telerik. Telerik is a company, they did a research on test automation best practices and also maintenance, and they published some numbers. And the first number I found, which was, I guess, maybe the most important one, it's quite big. 73.5% of all failing tests are caused of bad locators or a bad locator strategy. Yeah? And this is a very huge number with a huge potential, because this is exactly where self-healing tests is we are working against it. And I definitely want to decrease this number. Yeah? The next two numbers are more related to automation. The first is 40%, and here we talk about this is kind of a trend in 2023. 40% of all teams or IT teams will use some machine learning or even AI algorithms to get more agility, to achieve more agility and scalability. Yeah? So this is kind of a trend where we see a lot of things will get automated, and also some tooling will support us here. The next number is even much higher. It's 90%, and this is really interesting. This is from Gartner. They say that 90% of all IT companies will have a dedicated job role called IT architect. IT architect. Yeah, that's already automation architect or automation engineer, something like this. And then you have a reference number. Today, it's about 20%. Yeah, so this is a big trend there. And my topic with self-healing test is really in the automation part, of course, and test automation. Gartner went even further. This is quite interesting. They invented a new term called hyperautomation. What is hyperautomation? In my words, hyperautomation is the orchestration for the automation. Yeah, so it's kind of, you have an effective combination of a complementary set of tools to, so at the end, to achieve or to scale your automation, yeah, with tactical and also strategical goals. So it's kind of, you orchestrate your automation, yeah, because you have quite a lot of automation tools in place, and at some point in time you have to orchestrate it. And I did a Google Trend research on that, and you see some peaks in the past. Don't ask me what this is, but since 2019, you see that there is a trend ongoing. People are searching for that. So this is you see, hyperautomation is trendy, and self-healing test is has to do with hyperautomation. So this is what we motivated me. So I wanted to decrease maintenance effort, and doing the research, I saw that, okay, this is a hot topic, so there must be a solution. But before I come to the solution, I want to share the problem. And look at this picture. Look how old I look at that picture. No, just kidding. That's not me, but maybe I look like that if I, again, doing root cause analysis, and I find the exception with no such element. Yeah. So the problem, what I'm tackling today, is the no such element exception. What is this no such element exception? Yeah, maybe you know it, but still I want to explain it. It's a common exception in GUI testing. Yeah, for example, if you use Helenium and your automation scripts are not able to to get the element on the website, so it's not visible, or it's you have some latency problems, or yeah, the locator changed. And I mean, application changes after each release, more or less, yeah. And in days where we release very, very fast, the application continuously changes, and people change, yeah. And they can, if you get new people into the team, and you maybe don't have very good common agreements, or even that you kind of force it, then they can change locators. They can invent new naming conventions. And if you have a very mature DevOps team, you can, of course, predict a lot, that in the communication. But sometimes the communication between testers and developers is not that well, or even you use external software components like you have in your website. I don't know, Facebook like buttons and something like this, or other plugins. Those locators you don't have in your control, and if they change, of course, you have to do something. Yeah. So this is exactly the problem. And for that, I searched for the solution. And the solution is, of course, I spoiled it already on my title. Yeah, it's self-healing. Yeah, so self-healing tests. What is self-healing? What do I talk here? Yeah, and overall, you can say that self-healing is the automation for the test automation. Yeah. So self-healing, there is running a process in your on your server or in your test automation, and it fetches data, yeah, or it grabs data. So additional data, yeah, about the system, about the objects, about your website, and stores it. And based on this data, it will learn. So this also means how more often you execute and run the stuff, the more that data gets produced, and the better the learning algorithms can work and can deliver you then solutions or self-healed locators in my area now. And at the end, it's kind of a key to build an efficient test automation and test automation maintenance process. Yeah, so this is very, very important, and this sounds really cool. So the problem now and the solution. And then I started, of course, researching about tools. Yeah? And as you all know, nowadays it's a mess, yeah? A tool mess outside. If you search for something, you get so many tools, and somehow it's really difficult to choose one. And so there are several commercial tools like from Marble, TestIM, or Tricentis. This is, of course, no product pitch here. It's just that you hear some numbers, some companies. And I, as a code myself developer by heart, really like open source stuff. And I found one, yeah. And this is called Helenium. It's open source. And yeah, you can see here the GitHub link. Everything is published. And yeah, this is really cool. And what is Helenium? Well, let me explain it. Helenium is open source, as already mentioned, and it's based on Selenium and Java. Yeah, so this is kind of also a precondition if you want to use it. And it's a real-time engine. What do I mean with that? This is really cool. It runs with your test execution, so nothing has to be installed on any server or something like this. The integration is done on the test automation suite, so it runs with it. It's a library, and of course it needs some infrastructure based on behind. I will explain you afterwards. It has this machine learning algorithm in place, so it consumes tons of data, kind of, and learns. Yeah, I have not investigated how the algorithm is designed. I also don't care, to be honest. It has it in place. And for the developers, which is quite cool, they have an IntelliJ IDEA plugin, which is also easier than for the maintenance. If some healing is ongoing, that you see the results and then you can use them. The integration, how is the integration done? It's really easy. As I mentioned, nothing has to be installed on the server, also on the test execution servers. The integration is done on the locators. So if you use locators like find by or by, that's I guess the mostly common use locators. then you can use Helenium because the integration is done a level higher. So it's done on the WebDriver, and you can see it here. So in general, you have here your WebDriver, your Chrome driver. You also use a Chrome, and then based on that, you can create the self-healing driver, and then this driver you can use then afterwards for your locators. Yeah. So this is how the integration is done. Of course, you need some configuration files and so on where you tell the Helenium where the backend servers are and so on. But these are details. This is just what you have to prepare, and as I mentioned, this property file. So this is what Helenium is about. Now I want to explain you also how Helenium is designed from the components, that it's really transparent, because for me it took, I don't know, 1 or 2 hours to install everything. That was really cool. Yeah. So what is Helenium? How is Helenium the components are? First, everything starts with test automation code. If you don't have that test automation code, you should maybe investigate that and invest in test automation. It pays off. Here, you have to integrate it with your Helenium client. So it's kind of the Helenium jar. Yeah? So this is what you have to do. Then you have more or less everything done from this integration perspective. And what you have to, of course, install is a Helenium backend. This is a RESTful web service. And you can install it by your own, or they have a Docker support. So you can run it inside a Docker, which is very convenient. So you just have to pull the Docker image and run it. And of course, it needs a database. So this is kind of the Helenium Postgres database. See, everything is here also free. And this is also delivered by a Docker image, so nothing intensive to configure. And for those who are really lazy, like me, they also support or deliver a Docker Compose file. So you just have to download this YAML file and start it, and both of these Docker images get started, and you can interact with it through the RESTful web service. So this is, from that perspective, two things are missing. On the one side, as I mentioned, the IntelliJ ID plugin. Yeah, this, of course, you can download from the marketplace. It's integrated with the automation code. Yes, of course, and with the RESTful web service. So this is from that perspective, but that's optional. And also for the reporting, they have a Gradle and a Maven plugin, because they need to tell the backend when a new test execution is done or triggered, that they can deliver a better report. But also that is optional. You don't have to use it. And yeah, so that's the components, more or less. As I mentioned, everything very easy, straightforward, and easy to use. Good. As next point, I want to, and this is now kind of the most exciting one, I prepared an example. Yeah, that you really see where is Helenium working, how it, what do you get, and so on. And here I prepared the example also again with an open source project. Yeah, I guess you see a pattern. And this is a DigiBank, it's a digital bank app, also on GitHub. And yeah, I just prepared here a test case for the login. Good. So as I mentioned, this is our DigiBank running. It's a website. You can see here our test automation framework. You can see here, this is the Helenium backend. Yeah, so very sophisticated now here. And this is the find by locator. So you can see here, this is now with the password. And you can see here kind of the snippet of the HTML. You can see here, okay, yeah, that's the input, and the ID is password. Yeah, so everything is fine. Good. Now, we have a pipeline. Tests are always executed, so it gets triggered. What the test automation framework tries to find the element, and it has found the element. Cool, everything is nice. But this status, quite difficult to read maybe, this successful found gets also transported to the Helenium jar. And this gets also then forwarded to the Helenium backend. There it stores all the additional data. Yeah? So nice. Cool. So in your test execution, you see a green sign. Everything is fine. Good. Now new version. A new version comes. That's usual. And they implemented new naming conventions. If this is now realistic or not, we don't care. But the new naming convention for the attribute ID. They also add now the HTML time. So password gets password input. Okay, good. They, of course, deploy everything and the test get executed. It tries to find the element, yeah, and of course, what happens now? Bam! Exactly. No such element exception. But this is now in the logs, yeah? So you don't get that because Helenium is in place. And this status element not found or no such element gets forwarded again to the Helenium client. This gets forwarded to the backend, and there then the algorithm starts working, and it delivers new locators. Yeah, and these locators get then forwarded again to the test execution, and it tries to refine the element. Yeah, you also can define refine counters and so on, how often you should try it, and it found the element. Awesome. But why? What's in the logs? Yeah, and if you go inside, you can see that it first it in the red box it um, first use the password one. Yeah, so this then it tries to heal, and you see it's use the healed locator now with a score of 79 something. I don't know what that is. Yeah, maybe this is the algorithm. Yeah, and it used the CSS selector input password. Yeah, so with ID again. So that's very interesting. So it doesn't only take historical data, it also takes the data from the current run, which is really nice. And of course, an ID has a very high value. If I would remove the ID now, it would probably take the name. Yeah, or I don't know, most probably. And this is really cool. Yeah. So also, if I locate the changes, it tries to take the new one. And yeah, and the test is green. Yeah, so you don't see it. The test is green. You just in the report you would see that it healed it. Yeah, but from the execution perspective, everything is fine. Good, awesome. Two things are missing, as I already mentioned: report and the ID plugin. First, the report. The report is available also from this RESTful web server, but here you get delivered a GUI, and from each execution, you get then the healed report, and you can see here very nicely what was the failed locator. So you can see the password and ID, and then also the healed one, and a nice picture next to it, and also kind of a toggle where you can see if it's successful or not. I guess this is then that the algorithm learns from it a little bit better, that you also can tell it that it didn't work. But I have not tested that one. Yes, cool. From a recommendation from my perspective, that this report is a little bit, it's nice, but I would integrate it into your current reporting, whatever you're using, maybe to also implement a new status. Yeah, because in general you have the green ones and the red ones. Yeah, so the successful tests and then the failed ones. And I highly recommend to implement the search status kind of orange one, where it's kind of the healed locators. Yeah, you can get this data out of this server, and that you see it. Yeah, because it's quite nice to have this, really, but also it's very nice to use it for a discussion with the developers, that is tell it, hey guys, or in the next grooming or in the retro or wherever you want. Yeah, that hey guys, why we have 10 healed locators? Yeah, why have changed them? Yeah? Because of course you want to use it. Yeah, also not only for the healing, but also as a discussion basement. And how does the IntelliJ plugin look like? This is like this. So you have here your source code, and you can do a right click on the locators. You have then healing results in the context menu. And if you click there, you have then all locators healed ones from that. So you can see here the second one is this ID password input with the score 79. And the other one is, I don't know that one, to be honest. Yeah, good. So self-healing. What is self-healing? Self-healing is the automation for the test automation. Self-healing saves time in maintenance of the automation scripts. Self-healing solves definitely the no such element exception. And self-healing with open source means Helenium. And if you ask me now, is self-healing now this holy grail for test automation? Difficult question. Yeah, I would say, yeah, it's the right way. I really like, I mean, you see that automation, hyper-automation, there it's a high trend. It's a hot topic. And with Helenium, you don't have a huge border to get into that. Yeah, it's open source. You can really fast start it. Of course, if you're using Java and Selenium, and you can use it to get first experiences in this area. Yeah, I really like it. It's maybe not the holy grail, yeah, but it's definitely one of the right steps into the right direction. I really enjoyed it. It was a very nice experience from my side. I learned a lot, and yeah, that's what I can say to that.